Boys and girls, ladies and gentlemen of all ages, welcome to the magical world of Algebra 2. Today we're going to start our very first lesson. We're going to talk about function operations. What that means is we're going to start you off with the foundations of things we're going to build upon to get really good at moving letters and numbers around. That's basically all algebra is. So today we're going to focus on two things. We're going to focus on evaluating variable expressions. What this means in layman's terms is plugging in numbers. And understand, I get that you guys are Zoomers and a little young, but this symbol is not a hashtag always. In some contexts, like Twitter, Instagram, Facebook, whatever else you kids are using nowadays, hashtag. In mathematics, this is the symbol for a number, just in case you're out of the loop. The second thing we're going to talk about today is solving problems by evaluating expressions. Basically what this is rules. We'll say rules for doing math to expressions. And an expression is just like one side of an equation. Difference between an equation and expression is equations have equal signs, expressions don't. So we're going to learn how to add expressions, multiply expressions, subtract expressions, things like that. It'll be super fun. You're going to love it. You're going to have a great time. You're going to go up to your mom later today and say, "Mom, guess what? I had so much fun learning math today." And she'd be like, "Oh, Mija, I'm so proud of you." So let's go ahead and dive into it. Let's get some of the easy stuff out of the way. First, we're going to start with evaluating functions. What evaluating means is substituting a value in for x, then simplifying, and we're going to follow the order of operation. So just in case you forgot, and I'm not going to blame you if you forgot. I understand that you spent a lot of time learning other very difficult ideas in other classes. So we're going to review the order of operation really quickly, and then I'll have it on screen for us later when it's relevant, just so that we can kind of reference it. So our order of operation is an acronym, PEMDAS, and we start at the top and then go down this acronym. Each letter represents a math operation, and we're going to do those math operations in the order they appear in the acronym. So the first one is parentheses. I'm not sure if that's spelled correctly. This is math class, not spelling class, so who gives a hoot? Parentheses. So what that means is if I have like 2 plus 5 times 3, I'm going to add the 2 and the 5 first because they're inside the parentheses. Then I'll do the 3. E is for exponent. Pardon me, I have to sound out my words. So this just means if I have 2 times 3 squared, we would do the 3 squared first, and then we would do the times 2. So exponents first. M is for multiply. So multiplying comes before these other things. D is divide. I'm going to give you a little disclaimer. Multiply and divide, they're kind of equal rank in the order of operations. So there are sometimes you can divide first, then multiply, if that makes your life a little easier. So division can come first. It's not 100%, and in some cases it makes more sense to divide first, other cases not so much. And we'll talk about it when we get there, so don't freak out. A is for adding, and then you can probably guess S. It's for square. Just kidding. It's for subtracting. Subtracting. And just like multiply and divide are kind of reverses of each other, so we can do either one first. The same thing goes for adding and subtracting. These are also kind of equal ranking math operations. So there are cases where you might want to subtract first, then add if let's say something cancels out. So if we have like 3 plus 7 minus 7, it makes more sense to take 7 minus 7 and say this is 0 before doing the 3 plus 7. So there are cases where you can do the subtracting first before the adding. This, again, only works with adding and subtracting. You cannot say 3, let's see, go back. 3 times 7 minus 7. You cannot do the subtracting first here because subtracting is only equal to adding. Multiplying outranks subtracting, so we have to do the multiplying first. Okay? So here's our order of operation. We're going to follow this to simplify all of our problems. So let's go look at a couple of examples just to make sure you know what I'm talking about. All right, so here PEMDAS is off to the side. I just put the letters. Hopefully you can remember from one slide ago what the letters represent. So what we're going to do is we're going to evaluate the functions with the given value. So example number 1, they say f of x equals negative x squared plus 3x minus 4. And they want to know what is f of 2. So this right here, they've replaced this x with a 2. So what they're saying is that x equals 2. And everywhere in the problem that there's an x, we're going to replace it with the number 2. So when you do that, the first thing you want to do is copy down the function f of x. And anywhere you see an x, we're not going to put the 2 in yet. We're going to replace the x's with a set of parentheses. So let me show you how that looks. We're going to say f of x equals negative, where the x is, put some parentheses, bring down our squared, plus 3, where the x is, put a set of parentheses, minus 4. Now that we have parentheses, now we're going to put the number that x is equal to into these parentheses. This is to help us not accidentally get rid of math operations. If students go straight from this to what's going to be the next step, often what will happen is things like this negative sign or this 2 will disappear and then you'll get the problem wrong. Because math, you have to be perfect for 5 steps in a row sometimes. If you're not absolutely perfect, it's all wrong. So we need to be extremely careful to be perfect all the time in math. So we're going to put our parentheses. Now we're going to fill in our 2's. So 2, 2. Now that we have our formula filled out and we've done the substitution where we replace the x's with the 2's, we're going to follow PEMDAS in order to simplify this equation. So start with P for parenthesis. Inside of our parentheses, we have parentheses here and here. We cannot simplify anything inside. Inside these parentheses is the number 2. There's no math operation inside here for us to do. So parentheses is already done. We don't have to worry about that. Let's move on to exponents. We do have an exponent. We have this 2 right here. So what we're going to do is we're going to square the thing inside the parentheses. We're not doing anything with this negative, so we're just going to bring that down. So the negative comes down. 2 squared. The exponent means take this thing and multiply it to itself this many times. So 2 squared is the same thing as 2 times 2, which is 4. If we had 2 to the 3rd power, that would mean take this number and multiply it to itself 3 times. So it would be 2 times 2 times 2. The exponent tells us how many of that number we're multiplying together. All right. That's the only exponent we had, so we can cross that off. Moving on. Multiplying. Here we have 3 times 2, so we can multiply that out. So that'll be plus 6, because positive 3 times positive 2 is positive 6. That's done. We don't have any dividing, adding, subtracting. We're subtracting 4. I'm going to go ahead and just bring that down so we can look at this all together. Minus 4. All right. So we have f of x equals negative 4 plus 6 minus 4. So we can do it straight across. This negative 4 we could rewrite as negative 4 if that makes you a little bit more comfortable. That's kind of like a multiplying step. This negative is a negative 1 being multiplied to 4 to get negative 4. Or you can just slap the negative on there. So negative 4 plus 6 minus 4. Negative 4 plus 6 is 2. So this is 2 minus 4 is negative 2. And that's our answer. All right. Let's do one more just to make sure that we have the idea. So we're going to take this f of x function, 2/5 times the square root of x plus 3. And they're telling us to plug 13 into the x. So they're saying x equals 13. So our first step is rewrite the f of x function. And when we do that, we're going to replace the variable x, oops, pardon me, I miswrote there, with a set of parentheses. Again, it's important to do this like baby step in the middle, replacing with parentheses. Otherwise, students tend to lose a math operation. Now, where the parentheses are, we're going to fill in what x is equal to, so 13. And now we're going to go ahead and simplify following our order of operation, PEMDAS. So let's start by talking about parentheses. Parentheses is maybe slightly misleading. What this means is do anything that kind of holds a bunch of stuff together. So parentheses could be literal parentheses. They also include special math operations like square roots or absolute values. Anytime you have parentheses, square roots, or absolute values, you're allowed to simplify the insides of these as your first step. So for our square root, the first thing we can do is simplify the inside of this. 13 plus 3 is 16. So we have 16. We haven't taken the square root, so the square root should still be there. And we'll just bring down the 2 over 5 like that. Okay. Now, exponents. Exponents kind of include square roots and exponents. So we're going to do the square root right now. We will have an entire unit later dedicated to why that is. So don't worry about it. Just take my word for it. So we're going to do the square root. The square root of 16 is 4. So we have 2/5. This 2/5 is multiplying to the square root of 16. So it's going to be multiplying to the 4 after we simplify it. And if you're confused about how I got 4, the square root is asking what number times itself, x times x equals 16. So what number could I plug in twice here that would be 16? And the answer is 4. Now we need to do 2/5 times 4. So the way you do a fraction times a number is you turn your single number into a fraction. So we'll put it over 1. And then we multiply straight across. So top multiplies to top, bottom multiplies to bottom. So 2 times 4 is 8, and 5 times 1 is 5. And then in this class, we'll leave this as a fraction. I don't want it as a decimal. All right, so there's 2 good examples of evaluating functions. Now, let's go ahead and look at some function operations, and then we'll go through a few examples of how to simplify those. So for our function operations, there's just some notation we should probably talk about before you guys dive in. So we can add functions, and this will make more sense on the next slide when we're not just saying f and g when you have actual functions. But all you need to recognize is that when we say f plus g of x equals f of x plus g of x, it means if I have f of x equals x plus 1, and g of x equals x minus 3, f plus g of x means take this thing and add this thing to it. Okay, so these two ways of writing it are the same thing. This one is just a little bit shorter. Notice there's one x here and there's two x's here, so we save ourselves an x. The same thing can be said for subtraction. So f minus g of x equals f of x minus g of x. There is a trick we need to be very careful of with this minus sign, but we'll talk about it when we get to the example. Same thing goes for multiplying. F times g of x means take the f of x function and multiply it to the g of x function. And division, let me kind of give you a little disclaimer here. Division, we will learn later. Whoops. What you're going to do today for division is you are only going to set up the fraction. You're not going to do any simplifying. It is possible to simplify them, but again, that's for a later unit. We will also take some time at the end of the lesson to talk about what this g of x can't equal 0 means and what you should put if it does equal 0. So now that I'm done reading this slide to you and just giving you a bunch of definitions that don't mean anything to you, let's go look at some examples to kind of solidify our ideas. All right, we'll start with let's start with this adding problem, and then we'll come back to the subtraction problem. So it says we want to find f of x plus g of x. So what we're going to do is we're going to take what f of x is equal to. So here's f of x. It equals 3x squared minus 6x plus 1. So where this f of x is, we're going to replace it with the entire equation, or rather expression that it's equal to. So we're going to put 3x squared minus 6x plus 1. And I think it's often helpful to put it in parentheses because of the special step we have to do for this problem up here. Then we are adding, so I'm going to bring down my plus sign, put it in the middle. Then just like we did for f of x, we're going to take what g of x is equal to, and we're going to replace g of x here with the expression that it's equal to. So 8x minus 9. All right. Now, all we have to do here is combine our like terms. And what that means is we add or subtract x squareds with x squareds, x's with x's, and then numbers with numbers. So if we look at this, we have 3x squared. There isn't any other x squared terms here for it to combine with, so we're just going to drop that one down. We'll bring it down, and it won't change because it doesn't have anything in common to combine with. Next, we have negative 6x plus 8x. So what you do is you keep the x the same, and then you just do whatever the math operations tell you to do with the coefficients. So negative 6 plus 8 is 2. So we're going to have plus 2 because the 2 is positive. Then we have 1 plus negative 9. 1 plus negative 9, same thing as 1 minus 9. And then this is negative 8. And then this is our answer. Okay. If this is confusing to you, please use a calculator. You don't need to sit and struggle with integer rules in this class. If you know you struggle with them and you often mess up positives and negatives, just use a calculator. This isn't third grade where we're testing you on can you add numbers. You're allowed to use a calculator to get the answer right. And plus it saves time. All right, let's look at this subtraction problem. We're going to take f of x and we're going to subtract g of x. So just like we did for the addition problem, we're going to put parentheses. We're going to write down the f equation. So 5x plus 7. We're going to bring down our minus sign from the middle of the problem. Parentheses, we're going to write down the equation for g of x. So 3x minus 5. The reason that these parentheses are necessary here is because there's a step we have to do, otherwise we're going to get the wrong answer. Because we're subtracting 3x minus 5, we have to take this negative sign and distribute it into the parentheses, otherwise our signs are going to be wrong. So this first term, this f of x, we can just bring this straight down. So this is still 5x plus 7. When you distribute a negative, all it does is change the signs. So this positive 3x turns into minus 3x, and this negative 5 turns into plus 5. Now we combine like terms. So we have 5x minus 3x are both x to the first power terms. So 5 minus 3 is 2x. Then we take care of our numbers. 7 plus 5 is positive 12. So our answer is 2x plus 12. All right. Let's go ahead and we're going to just skip this one because I don't want this video to be too long. This is just another subtraction problem. It's the same as what we just did. So let's talk about this multiplication problem. So just like we did before, we're going to put parentheses for x, or pardon me, for f. And we're going to write down the function that f is equal to. So x minus 4. Now we have a times, so we'll put a times symbol in the middle. But this isn't necessary. It's just there to make us feel good. Parentheses, x plus 3. So now we have a binomial, or two different terms inside of parentheses, times another binomial. So what we have to do for this, some teachers call it foiling. Sorry, that shouldn't be in the middle. But and this is an acronym that stands for first, outside, inside, last. It's to help you remember the order to do stuff. Some teachers don't like this, though. Other teachers might have called it just regular distributing. So what we're going to do is we're going to take each term in this set of parentheses, and we're going to multiply it to each term in this set. So we're going to take this x, and we're going to multiply it to x. We're going to take it and multiply it to 3. That's this x times everything over here. Then we have to do the negative 4 times everything. So we'll do negative 4 times x, and then negative 4 times 3, and we'll combine our like terms from there. So x times x is x squared. X times 3 is positive 3x. So we're done with the x. Sometimes it's helpful to cross it out so you know you're done. Then negative 4 times x is negative 4x. Negative 4 times positive 3 is negative 12. And we're done with our foiling or our distributing, whichever way you prefer to say it. Our last step here is combining like terms. So that's just what we were doing on the previous problems. And we're going to do x squareds. There are no other x squareds here for it to combine with. So it comes down and we have x squared. 3x has a negative 4x to combine with. So 3 minus 4 is negative 1. Bring down your variable x. And then this minus 12 doesn't have another number by itself to combine with. So it just comes down the same way the x squared did. And we have minus 12. And then this is our answer. All right. We're not going to do this one. Again, it's just more of the same stuff. If you really feel like you need help, you can ask me when you get back in the WebEx. And we can do it if you need it, but I'm not going to force everyone to do it. We will take some special attention and talk about this one, and then we just have division, and then we'll send you on your way. So here we have to find f of x squared. What f of x squared means is f of x times f of x. So what we're going to do is what we just did with this multiplication problem, except we don't use the g of x. It's nowhere in this problem. So this is just extra information to confuse you. We're going to take our f of x and we're going to write it 2 times and we're going to multiply it together. So where this f of x is, we put parentheses, fill in the expression it's equal to, so x minus 4, parentheses, bring down our times. Then we're going to replace this f of x with the same expression again. So we have x minus 4. And now we do our distributing or our foiling again. So we're going to do x times x times negative 4, negative 4 times x, and negative 4 times negative 4. So x times x is x squared. X times negative 4 is negative 4x. We're done with that term. Negative 4 times x is negative 4x again. Negative 4 times negative 4 is positive 16. Then we just combine our like terms. So bring down our x squared because there are no other x squareds to combine with. Negative 4x minus 4 more x's is negative 8x. And then bring down the plus 16 because it doesn't have a number to combine with. And then this is your final answer. Not too bad. All right, we're going to talk about our dividing. Again, you're not going to have to do any simplifying. This will come much later in the class. For today, all we're going to do is we're going to set this up and then you're done. These are the easiest problems on the homework. So we have f divided by g of x. So let's set up our fraction bar. Make it wide enough that you can write these on the top and bottom of them. F is on top, so we're going to take our expression that f is equal to and put it on the top. So we have 7 minus x. On the bottom we have g, so we're going to replace the bottom with what g is equal to. So x squared minus 25. This would be our answer, except it says write the answer in standard form. What standard form is means you're going to put them in descending order by exponents. So it'll be x to the thirds, then x squareds, then x's, then numbers by themselves. You want to start with the biggest power of x, and then they should go down in order. So the bottom is fine. We have x squareds. We don't have any x's, so that's fine. And then we have numbers. But the top, the numbers come before the x, so we have to switch the order of these. Be very careful here. This negative is attached to the x, so we need to make sure it stays attached to the x. So this is going to turn into negative x, and then this 7 is positive because there's nothing in front of it, so we're going to put plus 7, and then the bottom will just stay the same, x squared minus 25. All right, let's do just one more to make sure you understand what we're doing there. So this time g's on top. So we're going to put our fraction bar. We're going to copy g, so that's 2 radical x plus 1. And then the bottom, we'll copy f. So this is radical x minus 3. Just check for standard form. X's, then numbers. X's, then numbers. So we don't have to rearrange anything, and that's your answer. You just copy them. It's very easy. All right. You now have a homework assignment. I think it's only 10 questions. It's not that bad, and you're going to do it in class. So it's only going to be homework if you don't finish it, and I'll be there the entire time to help you. But there's one more thing we need to talk about before you start on your homework. Let's talk about this problem. Let's say f of x equals x plus 1 divided by x minus 2, and they're going to say find f of 2. Okay. A couple slides ago, when we looked at our division, it says f over g of x equals f of x over g of x. But look here, g of x can't be 0. So the bottom cannot be 0. Let's plug this in and see what happens. So we're going to have f of x equals, where our x's are, we're going to put parentheses, plus 1 over parentheses minus 2. Now we fill in what they tell us to put in for x. So this will be 2. This will be 2. We'll simplify the top. So 2 plus 1 is 3. And then we'll simplify the bottom. 2 minus 2 is 0. Okay, this is a problem. In math, there are 2 rules you are not allowed to break. This is like the worst sin you could possibly commit in mathematics. I would rather have you tell your grandmother that you didn't even like the chocolate chip cookies she made you for Christmas than divide by 0. That's how serious this is. So when you get a problem like this, where you have a 0 in the denominator, you stop. The problem is over. Even if this were the second step and you had like 18 steps left, you're done. The problem is over and you can stop doing it. The answer that you should write when the bottom is 0, you just write the word undefined. You want to write this down and make sure you spell it correctly. This is the answer to at least one problem on your homework today. So be careful. I warned you about it. All right. We are done with our first excursion through the magical world of Algebra 2. So you guys are going to go ahead, hop back in the WebEx. I'll give you instructions on where to find your homework and everything. But before you do that, go ahead and smash that mother heckin' like button. It really helps out the channel. I'll see you guys next time.